In this video, we're going to touch on two different sections, 5.3 and 5.4. These are going to talk about two different parts within a triangle that also have some theorems to go with them. So the first one we're going to talk about is called a median, okay? And a median is a segment that connects a vertex to a midpoint, okay, within the triangle. So we can have three possible medians, okay? So here's a picture of all three. A to this midpoint, B to this midpoint, C to this midpoint. So where they intersect, that point where all three medians intersect, that point of concurrency is called the centroid, which is also known as the center of gravity, okay? So we have a theorem that goes with this, okay? The centroid theorem is that the centroid is located 2/3 of the distance from the vertex to the midpoint. So this actually gives us kind of three different relationships. So I'm just going to particularly look at this median A to Y, okay? So P is the centroid. So AP is 2/3 of the whole thing. So that's what the theorem says, okay? Well, from that we can deduce a couple other things. So this makes up 2/3. This little piece has to make up 1/3, okay? So that's what this part is saying, that PY is 1/3 of the whole thing. And then if I think about, okay, what's the relationship between 2/3 and 1/3? Well, 2/3 is double 1/3. So another way to think about this is that the long piece is double the short piece, or the short piece is half the long piece, okay? So there's kind of a couple different relationships, and that is true of all three medians, so BZ and CX, okay? All right, and we're going to do a problem with that here in just a minute, you guys. Okay, so now the other one, this is from 5.4, is a mid-segment. Okay, so both of these involve midpoints. A median is a midpoint connected to a vertex. A mid-segment is two midpoints being connected. So if I do all three in a triangle, it forms what we call the mid-segment triangle, okay? Triangle within a triangle, but all of these are connecting midpoints to each other. Okay, so we have a midsegment theorem as well. The midsegment is always parallel to the side that it's not connected to, and it's always half of that length, okay? All right, so let's try a couple examples with those theorems. All right, so back to the medians, the centroid theorem. How do I know these are medians? Well, there's a point of concurrency, and it's vertex to midpoint. So G then is the centroid, the point where all three medians are intersecting. Okay, so they want me to find AG and CE. So first I know AF, this whole median, is a length of 9, okay? So AG has to be 2/3 of AF, okay? Well, I know that AF is 9. That was given to me. So AG is 2/3 of, always means times. So 2/3 of 9, or 9/1, and then I can multiply straight across. So I get 18/3, which is 6. So AG has a length of 6. Okay? Now I'm asked to find CE. So CE is the entire median here. And I'm given that GE is 2.4. So this little piece is 2.4. So remember, the small piece is 1/3 of the whole thing, okay? So GE, let me write that out. Yep, okay. We'll do it up here. So GE is 1/3 of CE. So I'm trying to find CE, right? I know GE is 2.4. So I have 2.4 equals 1/3 of CE. So I want to know what CE is. So think about this algebraically. To get rid of 1/3, we multiply by its reciprocal. So I'd multiply by 3/1 or 3 on both sides. So 3 times 1/3 is 1. Got to multiply both sides by 3. So I get 7.2, I think, when I do that. So it kind of makes sense too. If this is 1/3 of the whole thing, I multiply 3 of them to get the length of the entire segment. Okay, so this problem says the diagram has a plan for a triangular piece of a mobile. Where should the sculptor attach the support so that the triangle is balanced? So remember, the centroid was called the center of gravity. So think about if we have a triangle plane and we stick a support underneath. If we stick it on that center of gravity, the triangle plane will be balanced. So we need to find what are the coordinates of that point where we should attach the support. Okay. All right. So we know the centroid is comprised of medians. So if I could draw in the medians and find out where they intersect, then I would have the point. Now, I know it has to connect a vertex to a midpoint. So I need to find the midpoint. So I'm going to find, and we actually only have to do 2. I could do all 3, but 2 is enough to give me an intersection. So I'm going to find the midpoint of RQ. So I'm going to use my midpoint formula. I'm going to add the x's, divide by 2, and add the y's, divide by 2. So this is the midpoint of QR. All right, so I got 6 divided by 2 is 3, 12 divided by 2 is 6. So 3, 6 is where the midpoint is, and then I just connect it to the vertex to get a median. Okay, so this is the median, and it would help if I was using a ruler here too. So that is one median. I need one other one at least to get the centroid, the point where they're going to cross. Okay, so let's find the midpoint of PR. So PR, midpoint. All right, so add the 2 x's, so 3 plus 6 divided by 2. Add the 2 y's, divide by 2. So 9 divided by 2 is 4.5. And 4 divided by 2 is 2. So 4.5, 2. All right, and again, this needs to connect to an opposite side. And actually, I do have a ruler sitting here. Actually, it's an architect scale, but it will suffice for a straight edge. So I'm going to connect that midpoint to the vertex. And I could do the third median, right? I could do R to the midpoint of this side, but I don't need to. I just need the intersection that is the centroid. So what are the coordinates there? It looks like 3, 4. So that is the point where the support must be attached in order for that triangle mobile to be stable. Okay. All right, here I have a triangle that has vertices J, O, Y. Find the equation of the median from vertex Y to side JO. So I'm just going to sketch a triangle J, O, Y. J is at 2, 5, O, 8, 3, Y, 6, 8. Okay, so we want to find the equation of the median that goes from Y to side JO. So I know it has to go through the midpoint of JO and then connect to Y. So they want the equation of this. Remember, the easiest way, since they don't specify, is point slope form. So I need a point and I need slope. Well, I have a point, I have Y that it has to go through, but I need the slope of this line. Now, medians aren't necessarily perpendicular to this one, so I actually need to find this point so I can calculate the slope of that segment. So this point is the midpoint. So I'm going to use the midpoint formula for, I'm going to call it M for midpoint here. Okay, so M uses the midpoint formula. So 8 plus 2 divided by 2, 3 plus 5 divided by 2, which gives us 10 over 2, which is 5, and 8 over 2, which is 4. So that means this midpoint has coordinates 5, 4. Okay, so now the slope of MY, so y2 minus y1, so I'm going to do 4 minus 8 over 5 minus 6, which is negative 4 over negative 1, which gives us a positive 4. So the equation, I'm just going to use point slope form because I have a point and I now have slope. So y minus my y1 is 4, slope is 4, and x1 is 5. And then if I needed to convert it to slope-intercept form, I could distribute the 4 and then add that 4 to get y by itself. But since they don't specify, I'm going to stop right there. All right, we got 2 more examples here, you guys. So that was all with regards to medians and centroids. Now we're going to switch back to the midsegment. Okay, so midsegment is connecting 2 midpoints. So UV is a midsegment and UW is a midsegment. I know they're midpoints because of the markings on either side of them. Okay. All right, So we're trying to find the length of UW. Let's start with that. So UW is the midsegment. So remember, the theorem is that this is parallel to the side it's not connecting, and it's half of that side as well. So if this side is 7.4, half of 7.4 is going to be UW. So all I need to do is 7.4 divided by 2, which is 3.7. Okay? Then it says find measure of angle SVU. So SVU is this angle right here. Well, I know that this midsegment is parallel to this side. So I'm actually going to turn it this way for just a second. You guys can still see here. All right, so parallel lines, transversal. So this angle is 41, and this angle must be equivalent to this angle because they're alternate interior angles. So if this is 41, this angle is also 41. So the measure of angle SVU is 41 degrees. Okay? All right, lastly, it says find the perimeter of the triangle. So we want to find the perimeter of RST. So perimeter is all three sides added together. So I need to figure out what all the sides are. Well, this one is given as 5, so this must also be 5. So 5 plus 5 gives us that side of 10. We know this whole side is 7.4. And then the third side, okay, well, the midsegment UV, remember, is half of RT, the side that it's parallel to. So 5.2 is half of what? So in other words, we need to work backwards. So all I have to do is do 5.2 and multiply it by 2 to get that third side, okay? Which 5.2 times 2 is going to give us that last side of 10.4. So we add all those together. So we got 10.4 plus 7.4 is 17.8. I think we get 28.8 there for the perimeter. All right. Okay, last example here. Draw the midsegment triangle below. Okay, so remember the midsegment triangle is all three midsegments together create another triangle. So midsegments connect midpoints. Okay, so I need to find the midpoints of these segments, and actually all of these are kind of nice, you guys. You might be able to eyeball, I think all of these we can kind of eyeball. But we could also calculate them as well. Okay, so and I am going to need to calculate because it says verify. So me just eyeballing is not justifying that this is actually the midsegment. So I'm going to do one and have you guys do the other one. So I'm going to call these something. I'm going to call these X, Y, Z. So I have points to refer to. Okay, so I want to verify that XY is in fact the midsegment. So remember, in order for that to be true, XY must be half of AC, and it must be parallel to AC. So, is XY half of, sorry, that's BC. Okay, so let's check. So how do I check this on a graph? Well, remember, length we can calculate using the distance formula. So here is the distance from X to Y. Okay, XY has the coordinates -6, 2. I'm actually going to write this out here. XY is -6, 2. Sorry, X is that. Y has coordinates -2, 4. Okay, B has coordinates -7, -2. And C has coordinates 1, 2. All right, so we are finding the distance from X to Y. So I'm going to use my distance formula. So I'm going to do X1 minus X2. So -6 minus -2 squared plus 2 minus 4 squared. Okay, simplify. So -6 plus 2 is -4. -4 squared is 16. 2 minus 4 is -4, excuse me, -2, -2 squared is 4. Remember, after squaring, it's always going to become positive. So we get square root of 20. And we can break that down, right? We can simplify. 4 and 5, 2 and 2. So 2 root 5 is what xy is equal to, okay? All right, so we need to calculate now BC. So the distance from B to C, use those coordinates now in the distance formula. So y minus y squared, excuse me, x minus x squared plus y minus y squared. So I get -8 squared, which is 64. 4 squared, which is 16, which is 64 plus 16, 70, square root of 80. Okay, so again, break this guy down. So I'm going to get 80 is 5 times 16, 4 and 4. Bring the 4 out front, so I get 4 root 5 is BC. Well, 4 root 5 is twice 2 root 5. So this here, that work right here, verified that xy is half of BC. Check. Okay, so we verified one part. Now the other part we want to verify is xy parallel to BC. So how do we check that? Well, we look at the slopes, right? If the slopes are the same, then those segments are parallel. So the slope of xy, we can just count using rise and run, or you can do the slope formula with the coordinates. I'm just going to count. So it looks like up to and over 1, 2, 3, 4. So rise over run, I can simplify that to 1/2. Okay. The slope of BC, counting, I'm going to go up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8, 4/8, which also reduces to 1/2. So I'm just going to write yes there. Okay, they are parallel because we verified their slopes are the same. Okay, so we could do that for all 3 midsegments to verify that they are in fact midsegments because they justify the theorem. So it's 2 parts, showing that the length of the midsegment is half of the side it's parallel to and that the sides are in fact parallel. All right, guys, that is it for this video. Thanks for watching.